So welcome everybody to this course in scientific programming in Python and Fortran. I'm very happy that we have so many participants in the course now. I think we're almost 40. So I hope I can manage all the exercises, but I think I will manage that. Let's see here, I have more people in the waiting room here. Let me all. We'll give it a couple of minutes because I see I have people in the waiting room. Okay, so the general plan of this course is we will have lectures every Tuesday according to the schedule in Canvas, and tutorials on Fridays. So they will be at 10 o'clock. And until, let's see, well, sorry, I just say correctly here. No, sorry, tutorials is also 1 o'clock to the same time as the lectures in the afternoons. I hope that everybody has been able to go into Canvas. So I will share my screen here just to kind of show how the Canvas session looks like. So this is the course homepage. It's divided up into, so the most important thing is the homepage here. And here you will see all the modules that we are going through this course. There are general information here. Here is the software part here on how to install the software required to take part in the course. You can run this course on Windows, Mac, Linux, and also if you have accounts on the Linux systems Aurora, you can of course use that as your main environment as well. And then we have modules here for the different parts of the course here. So what we are going to do today is introduction to Python. Then we have built-in functions as I/O, matrix computing with Python, plotting with Python, object-oriented programming. And I will make this available as soon as I'm kind of ready to put out the information. I'm updating some of these materials as well. So this is the most important part. And in every module there is a exercise part. And the exercises, there are a lot of exercises to do, but they are basically for training, and exercises that are marked with stars are those that are supposed to be turned in. So the other ones are basically to kind of you can work with on the tutorials and to train yourself in becoming better. So also there is I will try to communicate as much as possible using the Canvas system. And it's also a good idea that you can do that as well in this course. I will also, during the breakout sessions, the tutorials, I will enable so that we can take one-to-one sessions as well and share screen and help you out. So we'll see how to practically do that because we are so many now, but we will have to have some kind of waiting line or queue, and then I will kind of help you out during these 2 hours as well. So I will be teaching Python using something called, probably have heard of, is notebooks. So all my lectures are electronic notebooks. And an electronic notebook is kind of an interactive Python sheet where you can mix text and Python code together. So my hope is that when you open the links here, you can participate during the lecture, and you can also actually write code and modify the examples in my lecture live, so you can experiment with them yourself, also when you get back from the lecture. And I wanted to show you how you can create a notebook in Google as well, so you can do your own notebooks as well. So this is my Google Drive, and you can create a new here, and you go to More, and there is something called Google Collaboratory. If you click on that, it will open a new document here, and it shows you here. This is basically a Python prompt. So you can type here print hello, and you can execute the code here by pressing the play button here. Now it takes some time. It starts up a virtual machine somewhere, and then it prints the output here. You can also add text here, so you can add and then you can mix and match both code and text. So basically, you can create a report that contains the code to do the diagrams, and you can mix and match that. There is a video on this in the canvas here, how to create a Google Colab notebook. So you can look at that and see how to use it. So I will start with my the first lecture here. So now I'm opening this in a new notebook here. So the first thing I will do is it connects to make sure that I have an active Python interpreter. So up here you can connect to it, and it will create an interactive Python environment that you can run code in. So what is Python? So Python was created in a very long time ago, in 1991, by a guy called Guido van Rossum. And what he wanted was to have a language that supported code readability, and also to be able to write large applications in a clear and logical style. And one of the goals was to not have so much code block text that divided up the code. So basically, white space is important in Python. So instead of having a begin and end statement or a curly bracket to initiate a code block, you basically indent your code to kind of indicate the structure of your code. So that is done with indentation. The language also is something that I will describe much more in this lecture as well. It's dynamically typed. That means that variables can have different data types associated with the same variable name, which is can for people coming from a C world or a Java world, which are very strongly typed. This can be somewhat you have to get used to it a bit, but it's very effective, and it's not like it's untyped. It's just that your variable references the data type of your variable references can change during the program execution. It's also a language that supports multiple programming paradigms. So usually many of the languages out there today, they have kind of, this is the programming paradigm. This is a functional program language. This is an object-oriented program language. But Python can actually be many of these things at the same time. So it can be structured and procedural. It can be object-oriented, and it can be functional. So you can kind of mix and match those features if you want. There have been major versions of the language. So the big major version was released in 2000, the 2.0 version. And the next major version, which we will be using in this course, the 3.0 version, was released in 2008. And one thing that was a bit notable during the time was that they actually chose to make it not backwards compatible. So they actually removed a lot of the, well, they didn't take over some of the features from the 2.0 version in 3.0 and actually changed some of the syntax and some of the behavior of the language, which was a bit controversial, but I think many agree that it was the right choice to do. The 2.x version still exists today, and the latest or last version, I would say, is the 2.7.18 version. It should have reached end of life already in 2015, but they postponed it until this year. So this is probably the last time they will update this version of Python. We will be using 3.7 or 3.8 in this course, depending on what environment you have and so on. You can have either 3.7 or 3.8, but the languages are, there are no big differences between these small versions. And there are some things that I think is myself, there is a language philosophy here, and that is that beautiful is better than ugly, and explicit is better than implicit, simple is better than complex, and complex is better than complicated. And also, one important thing, readability counts. So because of how Python actually encourages or forces you to indent your code, it automatically encourages you to do readable code. There is a link here for more information on the Python history, and which is kind of interesting to read as well. But it has an interesting history. So, program structure. So Python programs, they are text files that contain rows of statements. And they are translated to machine code using something called a Python interpreter. And they are translated row by row. So compared to, for example, C, where you compile your code, your source code, also in text files, using a compiler into machine code program that is executed. In Python, line by line is translated and executed as machine code. So there is you run your Python source code directly using a Python interpreter. Empty lines are ignored, and you usually name your Python source code with the extension .py. And these text files are also called source code files. And a typical source code file in Python can look something like this. The first line here is basically for Unix environments. And it tells you the Unix environment which Python interpreter to look for. So in this case, I say, I want a Python 3 interpreter, and it finds the one in the path that contains this Python interpreter. The next line here is something, it's optional, but it tells the Python interpreter which kind of text encoding your source code file has. And it can be somewhat important to have that, because when you use strings with foreign characters in them, the interpreter knows how to interpret the strings, so that this string will basically indicate for Python interpreter which kind of text file it's using. Comments are prefixed with a bracket or the number sign here, pound sign. This is the comment character here. And then you write the code like this. So this is a for loop. I will go through that later on as well. And then instead of starting with a curly bracket or a begin end or any other structure, you have a colon here that indicates now there is a code block coming. So in this case here, the code block is indented here. So because there is an indent here, this part of the code belongs to the for loop. So all blocks are initiated with a colon character. And the colon character at the end of the line indicates now there's a new code block. And you can continue here. So if you have another statement here, this also belongs to the code block. So if we run this here, it will execute print I and print hello. So those belong to the same code block. So that is the basic structure of a Python program. So of course, Python is not only a language, it is also a library of functions. So the Python comes with the language, but also a built-in runtime library. And there is a lot of functions that you can call. And just before I will go through functions and stuff like that later, how you can create your own. But I just want to kind of give an overview how you call functions. So, for example, the print statement here, which I used before, is a function. And all functions have a parameter list, which is enclosed by parentheses. And inside those parentheses, you can list parameters that you can give to the function. So in this case, the print statement can take multiple parameters, and those are separated with a comma. So in this case, I have a string parameter here, and I have a number parameter here. And this becomes a call to this function. If a function doesn't have any parameters, you still need to specify the parentheses. So this is an empty print statement here. It will just print a new line on the screen. Functions can also, all Python functions can have return values. And those are assigned using the equal sign here. So in this case here, this is the absolute function here. And it will return you the absolute of 4 and assign the variable y that value. You can also have multiple return values inside for a function, and then you can assign them q, r here in this case, and those variables will be assigned by this function here. So this is just a short overview so that you can call the built-in functions as well. So variables. So a fundamental feature of a program language is to be able to access data in different ways. Data stored in memory, data stored in disk. And in Python, variables are used to refer to data. And it's not the variable itself that stores data, but it stores a reference to the data in computer memory. So it can be compared to a wardrobe ticket where you turn in your coat, and you can go back again and give you the person working in a wardrobe your ticket, and you will get your variable back. So the same thing here. You declare a variable, and it should point to something, and then you can reference that later on. Some key features of Python variable references. So you don't have to specify any data types when assigning variables. And this is something people coming from C, for example, or Java will have to get used to, that variables are kind of, the type will be determined by the assignment. And also you can change, a variable can refer to different things during the lifetime of the program execution. So in this case here, I have integer variables here. I just assign a equals to 1. That means that a now refers to an integer value of 1. And because this is there is no decimal point, Python will interpret this as an integer. B here is 15. It will also be an integer. Floating point variables will be automatically floating point when you assign a floating point value with, for example, with a decimal point here. That will be a floating point variable. So if you want to have 14.0, you need to have 0 here to kind of assign it. Otherwise, if you do like this, it will be an integer. So 14.2 here will assign a variable, a floating point variable C. String, same thing. You assign a string with. There are multiple ways, so I get to that as well, to assign a string, but you can have single quotes, double quotes, and you can have something called a triple quoted string, and that will be a string. And now E is a string variable reference. Lists is also something you can assign to a variable, and a list can be compared to a container of variable references. So F here has a list of 1 integer, 2 integer, and 4 integer, and then a string. But now the interesting thing here now, A was already assigned here. And now I can assign a reference to a string instead. And that is completely okay. And makes this language quite flexible, but also you have to be aware of some of these things can lead to problems as well. So flexibility also give you some, there are some risks with this as well, so you have to think about this. Variables can be named different ways, so you can have naming. These are the rules that you have to think about when you name variables in Python. So you can only have letters from the English alphabet, only numbers. You can have no special character except for underscores, and the variable can't start with a number. So for example, allowed variable names are first underscore name, last underscore name, number, I2. But these are not allowed. So you can't start with a number, and you can't have international characters in variable names. So now we get more into technical details on what a variable is. So as I said before, a variable is a reference to the underlying data. So when you assign a value to a variable, memory is allocated for the value that is to be stored. And a named variable reference is created, the variable, and the variable refers to this memory location. So if you look at the code here, I have A equals to 42 and B equals to 84. And if you look in memory, it looks something like this. You have this yellow box here is the variable reference. It points to a memory location in memory that stores the value 42. You have a memory reference variable B that points to 84. So there are basically two variable reference pointing to two different memory locations. So one can imagine what happens if we do the following statement: A equals to B. So what happens here now? A equals to B. That means that A now points to the same memory location as B. So, and now there is no connection to the 42, and that will be automatically deleted. So a reference or a memory location that is not pointed to by a variable will be discarded at some point. So basically, A and B both point to 84. So this was not a real assignment. So comparing to C, for example, if you do this assignment here, C will actually assign the scalar value the same value as B. In this case, A and B point to the same memory location. Then we can assign A to 21. Then you have a situation here. Now A points to 21, and B continues to point to 84. So what we can do to kind of check for what things points to is there is a special function called ID in Python that will return a unique identifier to a variable reference. If we do the same things here, same operations we did before, but instead we check the unique references. So if you look, A we assign A42, we assign B42, B84 and A42, and we print out ID of A. You see here that 109.50808 and 152 at the end, and then we do A equals to B. Now we can see that A points to 152 at the end, 152 at the end. So basically you can see that they point to the same memory location. And then we see here A equals to 21. Now there's a new memory location created here, 136. And we still point to this 152 here by B. So you just keep, most of the operations you do with variables, you don't have to think too much about this. It will work as expected. But there are some cases here when you assign variables with each other that you have to think about variables in Python are references to data. And you can when you use the equal assignment, it's not an assignment, it's an assignment of the references, not the values. So we were into floating point and integers before. I don't have to do too much about this. Operators and expressions work in basically the same way as for any other languages. It will convert to floating point if it's a floating point value here. So it will not, even if you have only integers in your expression, it will upgrade the data type to floating point if it's required. So if it's not an integer result, it will be a floating point value. This is some of the behaviors that change from Python 2 to Python 3. So in old Python, many of these will be integer operations, but they are floating point operations now. They return floating point values when you execute them. You can have flags or Boolean variables in Python. Those are there are special keywords, true or false, that you can assign a variable to make it a Boolean variable. So in this case here, when I assign C equals to true, this will be a Boolean value and a Boolean variable reference. And you can assign false, that will assign the false to the Boolean value. And you can test those with if statements later on as well. Boolean values can be good to kind of, if you have want to have configure a program to do a certain execute some code or turn off some functionality. That's usually something you can use a flag for a Boolean variable. Now we come to the one of the most used data types, I would say, in Python, or most flexible data type, and that is a list. And the list data type is created by assigning a variable reference a bracket or an empty bracket, and you get an empty list. So in this case here, values now is a list, but it's empty. You can create lists directly by between the brackets entering values that you want to store in the list, and the list can store anything, any data type in Python. So it doesn't have to have the same data types for each element in the list. It can have integers, floating points, strings. It can have other lists within lists. So you see here now it prints out the list's content here. You access the references in the list by specifying a bracket in the variable here. So you have the value is the variable reference, and then you want to access the third element in this list here by specifying a bracket and the number, the index number, index of the item in the list you want to access. So in this case here, 2 means the third element, because all lists by default have a starting point of 0. So all indexes and ranges and in Python starts from 0. So if I try 1 here, should return a 3, and if I return a 0, oh wow. Now I'm You can also assign variables to a list directly. So you can have a value 4 of a list can be assigned directly here, a reference to a string here. So in this case, I assign the 5th position of values, the string pop. Now you see here 0, 1, 2, 3, and 4 here will be a string here. There are some interesting things you can do with a list as well. So indexes can be negative. That means it will wrap around the list. So if you want the last element of a list, you can have a negative index, and it will return you the last value. And if you have more negative indexes, it will kind of wrap around and go from the other direction of the list. So in this case, -3 will be -1 is this one, -2, and -3 here. So if I run this one here, it will return a 4 here, which is kind of consistent. So how does a list work in memory? So as I said before, everything in Python is accessed by reference. So in this case here, I have a values list here. I created here. So values will point to this list. And every item in the list is also a reference to a memory location. So in this case here, 1 here points to a memory location storing the integer value of 1. And this yellow one points to an integer 3, and so on. So what I do here is I say, if I do an assignment here, B, as this is a new variable reference, I assign this the value, the reference at position 4 in the list, so 0, 1, 2, 3, 4. So that is hello. So B now points to this memory location. So I do the same trick as we did before. I just ask the variable for its unique ID, and compare that to the value 4 in the list, and see if those are the same. And you can see here that yes. So here you have to be a bit careful, because if you store things from a list, you basically have 2 references that you can change. So if you change one of them, it will also change the other one. So this is how it looks like in memory here. So you have the yellow here, that is the B, that points to this memory location here, and you have the values reference here, list reference here, that also points to this memory location, hey, here. So that is something you have to be a bit careful. We can just try one thing here. So for example, if I do B equals to print out the list here again. Oh, sorry. Okay, no. This is a good example. So if I do this here, now B will point to a new instance of hello. So this will work perfectly. This will not modify this one here. But if I do instead do like this, values for equals to print B here. sorry, I just let's see if I did it correctly like this. Okay, I have. This was. I will get back to that. This will assign hello to value 4, but this B will keep the reference to the original here, so it's a bit confused. I will forget that. I'll get better example for that later. But basically, this structure that actually is the one. So they point to the same reference. Okay, so you can also access elements using different indexes. It's called index notation or slicing. So for example, you can print the values from 1 to 3. So 1 to 3 in this case means starting from 1, but not including 3, which is some of the odd things in Python that is never explained to me why they have this construction, but that is where it is. So you can also have from 1 to up until the last element. You can have from 3 and all of the rest of the elements. Just putting a colon will take all elements, and this will go from 0 to up to 2 from the end here. So 3 to 6, and this one without the last one, and so on. So this is a very flexible way of actually getting sub-lists from lists. So if you have a list, you can also, it's very often a case that you want to know the length of the list. And in Python, there is a special function that is used for basically generic function for all kind of data structures you have in Python. So in this case, len here is returns to the length of the list. You can also return your length of a string, length of a dictionary, we will come to later on, another data structure, and so on. So in this case, it will return 7, so that is the number of elements in the list. You can add things to the list. There is a special method. A method is, because Python is object-oriented language, so everything in Python is an object. And on an object, you can call special functions, and those are called methods. So in this case here, if I want to call a function on an object, I type values, and then I add dot append here, which is a function on that object, and that will add 42 to this object here. You can also insert something to the list using the .insert method, and that insert method takes 2 parameters. So it takes one parameter where you want to insert the item to. So in this case, after the first existing element in the list, it will insert the string squeeze here. So it will squeeze before 1 and 3 here. So this was the before position 1. And you can remove stuff from a list by using the .remove method. So here you will tell the Python which item to remove, and it will remove that. It's also possible to use the generic function del to delete specifically at certain position of the list. In this case, you type del and then the value you want to delete. So in this case, 0. So now it removed the first item here, 1, and the rest is 3 here, like this. You can also use del and a subrange or a slice to actually remove multiple items of the list, like that. You can also use there is a special method to emulate a stack data type. So a stack is a data type where you add and remove things from the end of the list. And there is a special method pop just for this purpose. So if you do values.pop, it will actually remove the last item from the list and return that that value. So you see here, list before pop, it has 3 items, and then we pop the number 4, and the list just consists of 3 and 6 now. You can clear a list as well. There are different ways of doing this. You can do the clear method, but you can also assign an empty list as a variable reference. But that doesn't mean that, assign an empty one doesn't mean that the existing list goes away directly. So in this case here, I have A equals to a list, and I assign B equals to A, and then I assign A equals to a list. So in this case here, the list is still there. So I just move the reference over to B, and then B is still there, but A is now empty. If you want it to be really emptied, you instead use the clear method here. So I have A equals to this here, B equals to A, and then I do A clear. And now, just what do you think will happen to B? Now B is also empty, because if I do clear on this list, it will clear both of this list and make sure that it's empty. As I said, list is a very flexible data type. You can also, a list can contain other lists in multiple dimensions. So you can, in this example here, I have a list A that consists of integers 1 and 2, and then I have a sublist here, 3, with the items 3 and 4, and then integers again, 6 here. So in this case here, I print out the number two element of which is 0, 1, and 2. So this is the list here. So when I print this out, I will probably see a list here. Yes, 3 and 4. And if you want to access items in a sublist directly without going through a multiple assignment, you can just add multiple brackets to your reference here. So in this case, I access item number 0, 1, 2 here, which is this one here, and the item 0 of that list in the second bracket here. And same thing here about the second element of that list. So in this way, you can create very quickly two-dimensional or multiple data or very complex data structures in a simple way. For example, I can create a spreadsheet here. So a spreadsheet here, which is first an empty list. Then I append zeros to this list here, and this is a special operation you can also use. So the multiply operators, if you have a list on the one side and the number on the other side, would actually create a list of 10 values. So this will be 10 zeros, and then and a list consisting of 10 zeros. And then I just append 4 of these as rows, print out the spreadsheets, and then you can see here, if I print len here, it will return the number of rows, and you can access this data structure as a spreadsheet. So you see here now it consists of 4 lists with 10 values in each of these, like that. And then you see there is 4 rows in this spreadsheet, and I can access spreadsheet row number 0 and element number 5. One thing that I will just note is that you should never use lists as matrices in numerical computing. So lists have completely different purposes in the code. It's for creating more flexible and complex data structures that you can't create otherwise. And I will go through in the next lecture next week. I will go through what you should do to do matrices and numerical computing in Python. So, but just don't try to create big data structure that you want to do computing with, because this is flexible but not super efficient when you have a lot of numbers in them. So just remember that. So here, another example here of this, you can have nested. This is a better example of this problem I had before that I failed to show. I have a list B here, 3, 4. I add B to my A list here. So I have a list here, which I put this reference into here. And then I assign B0 minus 1. You see here now, this list has a reference to B, and if I change something in this B list here, it will also change in the A list here. So you have this structure here. You have 1, 2, 3, and it points to this list here. And if I change something in this one, it will also change in here. If I don't want this, if I want another behavior when I create a new list, I can use the copy method to make a copy of the things you add to the list. So in this case here, I have B 3, 4, and then I do A equals to B copy instead of B. Then it actually copies the values and creates a new list that it inserts with the same values as B, but it will be a unique list. So if you run this here, you have 1, 4, and if I change B0 to -1, it doesn't affect this list here. It's a separate copy. So the structure will be like this instead. So there will be pointed to a new copy of the B list instead.
I have a question.
Yeah. I can't hear you. I think that. Yeah.
Sorry. What if I want to add B to A, but not have it as a list inside a list? I just want the data inside A.
So you don't have to, and then you can do put the numbers directly. You mean, let's see here. Like this.
Yeah.
Then you will have the same. Then you have don't have this problem now.
Yeah.
But this more if you want to preserve the structure with the list without having a reference to the same list, then you can use the copy.
Yeah. Okay. Yeah. Thanks.
Okay. So should we take a 5-minute break and continue 10 past? Yeah.
Great.
Okay. So the next data type we go through is strings, and it's probably what you heard before. It stores sequences of letters, and our strings is one of the kind of it's a large feature of Python, and there are so many ways of creating strings in Python. I will go through some of them, but there are more than I can show in this course. So you have to look at the documentation for more. So one thing that is a bit odd with strings compared to other languages is once you have created a string, you can actually not change it. So it's immutable. So in this case here, I create a string just by assigning double-quoted letters between double quotes. You can also use many different quotation ways. So you can also use single quotes. And this is kind of what you choose can be depending on what you want to enter for letters. If you want to use double quotes in a string, it can be better to have single quotes for creating a string. So in this case here, if I want to write "don't give up," I can use double quotes with strings. Then I can use single quotes inside. And another one around, if I want to use double quotes inside a string, I can use a single quoted string like this. So strings in Python are always interpreted in some way. Or the default string in Python is interpreted and can contain different control characters to control the behavior. So if you want to write special characters in a string, you can use special control characters. So in this case, there's a table here with, if you use 2 backslashes, you get a single backslash. If you want to have a single quote within a single quoted string, you can backslash it, add a backslash before it, and it will appear in the string. Same thing with double quotes. You can add a new line by using \n. You can have a tab by using \t. So in this case here, I have a string here. I have a control character here, \n. So this will actually, if I print this string, it will print this in 2 lines, like that. Sometimes you don't want Python to kind of, please ignore everything. I don't want you to check for any control character. I want to have a string that can contain control characters. And then you can use something called a raw string. And then you add a small r before the string, like here. And that indicates to Python that don't do any interpretation of this string. Just store the character as is in the string. And you can see here the differences here. So the first string here, it prints out actually the control character here. And another string here will actually interpret the control string here and add a new line. The final string type I will describe is something called a triple quoted string. And that means that you either have you prefix a string with 3 double quotes, 3 single quotes, and then you end the strings also with 3 double quotes or 3 single quotes. And the nice thing with these strings is that you can actually the control characters is controlled by the format of your string in the source code. So in this case here, I have a string here, I have a new line here, and end here. So these new lines will be added to the string. So if I print out this string, it will actually print on 3 lines here. And these kind of strings can be used, for example, you can if you have a configuration file you want to write for your computation, you can write a configuration file just like you would do in the file system, but as a triple quoted string, preserving the exact layout of the configuration file. So it's great to use for file templates or stuff like that. It's used in a web-based system as template for web pages, for example. You can get the length of a string by using the same function as we had before, and you see this coming back again. You have the same functions for doing several things on different data types. So in this case here, I query the length of these strings by using the length function, and it will just print out the length of the strings. As I said before, you can't change the strings once it's created, and actually this is not a big limitation because it's so easy to create new strings in Python by combining other strings. So in this case here, I have two strings here, S1 and S2, and I can create a third string by adding them together. We can also repeat strings. It's just the same as we did with the list. You can repeat items in a list by the multiplier operator. You can do the same thing with a string. So in this case here, I have a string here that I want to underline with the same number of characters as the string. I can do this by multiplying the dash character the same number of times as the length of the string. Another thing that is very important, for example, if you are processing files, when you read files, you read text files containing text. And suppose you have numbers with spaces in between. You want to read a file and you want to split that into their own numbers. You read it in as a string, and then you use the split method to split it up into smaller parts. So in this case here, the string is also an object which you can call methods on. So in this case, split, you call that on the string object. So in this case, I created a string here with letters, and I want to create a word list from my string. So I call the dot split method, and that will split by default on spaces in the string. So when I run this here, it will create a list of the string with each item in the list is the word that is in the string. So for example, if I have a line that I read from a file, and the file is a comma-separated file of some sort, then you can use the split with a parameter on what character to split the string on. So in this case, I would like to split the strings on comma instead of spaces. That works perfectly as well. So now it will split on the comma instead. You can go the other way around as well. This is a bit kind of an odd syntax you have to learn here, but there is a special method called join, which can be used to create a string from lists as well. So in this case here, I have a list of words here, or two lists of words, and I can join these words with spaces. So I take a space character, and that is an object, and I call the join method on this one, provide with the parameters of my list, and that will concatenate those together with spaces. I can do the same thing with a comma here, and then you get commas between the items in the list, the final string. And if you do an empty string, it will join without spaces. So you see here, the first one here we join with spaces. The next one we join with comma, and the final one we just join them together without any spacing. So that is a way of going from a list back to a string. It's also possible to search strings. So in this case here, I have a long string here with a lot of deep text, and I can check for existence of a word by using the in operator. So it's like speaking. So is vocalia in S, that will return a true or false depending if this string is in the string. So this is basically how you can almost like talking to Python. So is vocalia in S. So if I run this, it returns true. So if you do something else, it should return false. Yes. There is another, so vocabulary will only, so this in will only return the first instance of something. If you want to the exact position of a certain string search, you can instead use the find method. So find will return the location of where the string is found. So if I do far here, it will first find this one here, and it will return the position of that where that first instance of far is. So it's number 4, so 0, 1, 2, 3, 4. So this is the first position of this word. It can also take a second parameter here. So you can continue the searching here by putting the found position of the first item into as a second parameter here, but adding a 1, so it doesn't search again exactly from that position, but one more. And so you can find all these positions in the string. And if it doesn't find a substring in the string, it will return a -1. So you can check here if you search for something, it returns -1. It wasn't found in the string. Another important operational strings is removing leading and trailing spaces, which is something you often get when you read and read from files, that you need to kind of clean up the things you're reading. So you can do this with the strip method. So so S1 here, you have a lot of leading space, and you also trailing space here, which we want to remove. So we create a new string here, which the strip method will return a new string without those. So we can see here and compare. You see, this is the original string, and this is a string that is stripped. So it removes all the trailing and also the tailing spaces. There are special methods of this that you can only do. For example, right strip will only strip on the right side, and you have L strip will strip on the left side. So as you know, this one removed the trailing space, and this one removed the left trailing space. As I said, the data types of references can change, and there is a way of actually checking for the actual data type by using the type function. So it's just for information here. It can be interesting to query here, but so in this here it can return actual data types of a variable reference. And as I said, Python is definitely not typeless. It's but it's dynamically typed, so it has very strong types, but you can change the types during execution of the code. So the final data type I will talk about today is perhaps even more flexible than the list, and it's the dictionary data type. And the dictionary data type is you can compare it to a phone book where you store your phone numbers your last name, and you get the phone number when you can quickly come to your certain key of the phone book and find your phone number. So in a dictionary store values by key value pairs. So everything you add to this dictionary is associated with a certain key. Lists, the keys of lists are index integers, but you can compare a dictionary as a list where you can have an index that is a string or something like that. Difference from a string is that you create your dictionary by using a curly bracket pair. So an empty dictionary is created like this. It doesn't contain anything then. You can create dictionaries directly when you create a new dictionary by specifying the key value pairs. So you have this is the key, and this is the value, and they are separated with a colon, and every key value pair is separated with a comma. So this is the first key value pair, this is the second one, and this is the third. So you print it out, you see here, it lists all the key value pairs here. The nice thing with the dictionary is that you can actually access the keys very quickly. So if I want to access the values of David and Petra, for example, I can just use the same syntax as for list, but you specify the key inside the bracket pair. So you only use the curly brackets for creating dictionaries. Accessing is using the same syntax as for lists, the square brackets. And the nice thing, this access here, so if you have thousands of items in your dictionary, this operation finding if some key exists is very quick. So if you need to quickly find things in your data structures, consider using a dictionary. Just as for the list, you can assign values to dictionaries by assigning directly into it. So in this case here, I want to assign Peter here a value of this here. So this will be the key, and this will be the value. Now you also see that the other values here were strings. In this case here, I added integer value for Peter. So you can mix and match data types in a dictionary as well. So you can have a dictionary consisting of lists, other dictionaries, and so on. So it's a extremely powerful data structure you can use. So how do you find things in a dictionary? So in this case here, I have an index here of 3 key value pairs. And you use the same operator as before. There is this in operator you can use to query for things in the dictionary. So in this case, is Petra in index? It will return true, otherwise it's false. If Buster is in the index, it will return something else. Let's see how it works. So this is a way of quickly checking if something exists in the dictionary. And you can have one thing I sometimes do when I have more complicated problems. I have same data types, and I create key value pairs that are one dictionary that has one key, and then I create very quickly another that has the value as a key instead. Then you can have a quickly search in both of them because it's so quickly to create these structures. So yeah. And you can have you can use the same functions to actually query the number of items in a dictionary using the len here. So len you see come back all the time here. So if we len the values here, we have 4. So values had 1, 2, 3, 4. Yes. Adding values to a dictionary. So there is no append method here, but values are added by just assigning new keys in the dictionary. You see here, just I assigned the Guido key a new value, and it added to the list. As I said, you can have nested dictionaries. So in this case here, I have a configuration for a program. This is just a fictitious example here, but you can use it like this. So in this case, you have a config. I have a key general, and the key general is also a dictionary with the keys username, template, constants, items. And now you can see here that I can use it here. So if I can print my config general username. So I can create this multiple level data structure to actually access different parts of this data structure in a very easy way. So we are gone through most of the important data types in Python. So I'm continuing now how to actually create algorithm code. So you need to have loops and conditional statements as well, and how this works. So before we go into that, I will repeat again this the structure of Python code. So code blocks in Python are not like code blocks in other languages. So in C, you have curly brackets to define a code block. In Pascal, you have begin and end, and in Fortran, you also have a similar construct that you use your source code to special statements to create code blocks. So in this case here, I have my for loop, and the colon here is the important key to creating a new code block. So a colon in the source code requires you to actually, the next line must be indented to belong to the code block. If I don't do this and run this code here, it will be very mad at me, and it will say expected an indented block. And that's because I have a colon here, and when I start a colon on a line, Python expects you to have a code block on the next line, which must be indented. Usually, I set it for 4 characters in my editors. So usually, you can have any indentation here, but it has to be consistent. My rule is to, when you write Python code, set your editor for a fixed 4 character indentation, and don't change it in your source code, because it becomes problematic when you mix different indentation styles. So print here is part of the code block. But now if I want to continue my code again outside the code block, I just continue writing in the same level as the for loop here. So loops, we already covered it somewhat here. Repeating a code block a given number of times, you can use the for loop for that. So you can have a for loop that iterates over a range, and here you have for I in range 10. So this will so range is a special function that will determine the range that the loop has. So it starts from 0 and goes up until, but not including, the value in range here. So in this case, it will go from 0 to 9. So it will contain 10 elements, 10 loop iterations. You can have a starting point for the for loop here with a 5. And I want to go to 10, but not including 11. Like that. You can have a step. So the final parameter to range is a step length. Like that. And range is usually used when you need an index variable for accessing things in loops or data structures. But you can, in Python, you can loop without using a loop variable. Or not using a range loop, but you can loop over the elements of things directly. So you can iterate over a list. And here I have a list here of values. And I can loop over this value list directly here by using for value in values. That means that value here will be, in the first iteration, it will be this value. The next time it will be this one, and so on. But you don't have to remember the index. It will iterate over every element in the list and print them out. So this is quite nice. And interesting enough, if you have programmed C++, the newer versions of C++ actually include, has taken the concept of the for loop in Python and have a similar concept of in, to loop over values in a vectored list in C++, for example. So some of the concepts have been taken to other languages as well, which is kind of nice. You can, of course, you can loop over a list using a loop variable using the range construct. So in this case here, I want to loop over A, and B, and then I can use a range loop here, loops over length of A. So length will return you the number of items in the list. Range will loop from 0 to up until, but not including the last item here. Like this. You can also have two loop variables at the same time. So if you want to loop over two lists, you can use the zip function to combine the results into two loop variables. So in this case, I have X positions, Y positions stored in two lists. I can loop over both of them by using the zip concept here. And we'll see what happens when we run this. Like this. You can also loop over nested lists. So in this case, I have a point list that contains points. And then I loop over my points here. So P will be this one here. And then I loop over chord here in P to nested loops like this. You see also here the first code block here is this one here. The second code block here with colon is this indentation here. You can also iterate over the iterations by using the while statement in Python. So in this case here, I have so while will loop until a condition is until the condition is false. So while true, it will continue to loop. So in this case here, I do an iteration here over something. So like this. So it will iterate until this here will be greater than error. While this is greater than the error constant here, it will loop. And then it will exit the loop when it's done later. Oh, stop. Go back. So those are the loop constructs you can use. You can also, another important thing is conditional statements, so if statements. And they very simple as well. So in this case here, I have if I equals 0, the indented block is printed when this condition is true. I can have an else. So if I equals 0, it will print this one here. Otherwise, it will print this one here. Then I can have multiple nested if statements as well. So I can have if I equals 0, it will execute this code block. If it's less than 1, it will execute this one. Otherwise, if it's greater than 1, it will execute this one. And if you can't find anything else, it will print this one. You can also have nested if statement. So here you have to kind of make sure you format it correctly. So in this case, I have if I equals to 1, it will execute this code block. Else, if this is the code block that will be executed if this is not 0. And this will belong to this entire code block here. It's also possible to control your loop iterations here. And there are some statements here that you can use. So break is a statement that will exit the loop. It will terminate the loop and continue after the loop. So in this case here, I loop from 1 to 0 to 19. And if I equals to 10, I will exit the loop by calling break. So this will continue execution here. And then if I equals to 5, it will use the continue statement, and continue statement will just go to the next iteration of the loop. So this is a way of kind of, okay, I'm done here, just continue to the next one. So now I see here it loops, now it's 5, go to the next iteration, and it's 6, and now it's 10, exit loop, and now we are outside the loop here. I would try to avoid using too many of these because it can kind of lead to a bit of a spaghetti code, but in some cases it's the only way of creating compact and efficient code. So you should be aware that these statements exist and can control loop iteration. Functions and subroutines. So when you create your own programs, you will probably want to divide up your code in more manageable chunks. And that is often done by creating your own functions. And in Python, functions are created by using the keyword def or define, naming your parameters, naming your function, and specifying the parameters in the brackets. And then finally, you add a colon to so the code the function definitions must be a code block follow the define statement. So this is a typical one here. I have a define, and this is my function name, print doc. I don't have any parameters, I just have an empty bracket, colon here. Now I will define my function in the next code block. This is the next code block. So it's indented here, and this will belong to the print doc function. So now I define it, nothing happens, and then I can just call it just like any other function in Python, like that. You can add parameters to your functions. So then you just list them in between the brackets here, and then you can call them. So B will be passed to the function and printed out here like this. So next one you can think a bit on, because this is not obvious all the time, but do you think the value will be changed if I do something like this? So if I print value A here, what will happen if I assign A equals 84? So this is an example here. So I have B equals to 42, print value B, and then I print B again here. And we'll run it and see what happens here. So B is still 42 because you pass over the value here, and this here will actually create a local variable inside your function block here. So this will never be seen outside the function. So you can't assign values coming in. There are always input parameters coming into a function. So they will not be, you can't assign them. So if you want to return something out of the function, you can either use a list, which you modify in the function, that is possible, or you return values outside using return values. So in this case, I will define a function f of x that will basically just return the sinus of x. These are the standard math functions that you can use in Python. So from math, import star will import all the built-in math functions. We will, when we go through NumPy numerical, we will use this different functions here, but for this time, it's enough. So I define this, and then I use the return function here to actually return the values outside back to the calling, the caller. So in this case here, y equals f of x, then x will go into here, the y will be assigned the value from this function here. And you can use your own functions in very complex expressions, so that will work. So a little bit about organizing code in modules. So the basic concept in Python for structuring your code is actually, you don't have to think too much. Every source code you create is also a module. And every built-in function in Python is organized in a module in some way. And those are basically source code files that you can refer to. So in this case here, I can import a module by using the import statement. So in this case, I import math. And what happens is that it will make this module available inside your current execution environment. That also means that you have to actually prefix. So you want to access a function inside a module, you need to prefix math, the function with the module name. So in this case, math.sim. So I must add math to actually access my sinus function. That is one way of importing a module. You can also import using the from construction. So from math import star, that will import all the functions available in math directly into your code environment. That means you don't have to specify math, prefix all the functions with math. This can have a side effect, which is generally not always recommended to do like this, because it could be, for example, if you have NumPy, which also defines math functions with the same names, they will be overwritten. So when you do the from math import, it will actually replace those functions that you imported before with the math ones. So the general recommendation is always to use the import form if you can't avoid it. But you can. The general recommendation is it's a bit. So when it comes to math functions, sometimes it's really annoying to have to specify math, the prefixes. So sometimes I'm lazy and I do the from math import. But you should be aware that it can clash. It's recommended to use the import math and prefix your modules with math. So in this case here, I have a module prime.py. So I want to create my own module, and the only thing you have to do is just put your functions inside a source code file that you name with your module name. So you have to have a name. The name of the source code file will be the module name without the .py. In this case here, I have a source code file like this, and I will download it like this. So now I have a prime.py here in my directory, and I can do import prime. And now you see here when I execute it, I don't know why it's printed out that one. Should do it, but okay. And now we can use this module. So now it loaded all these functions into my code environment, execution environment, and then I can use prime.isPrime to check if it's a prime number or not. So it's not more complicated than that to create modules. In many other languages, you have to use a special syntax to do modules. In Python, you can just use create source code files and import them. That is a module. But there is also, as a Python is a scripting language, one of your source code files must be kind of the main program, or where you start your code from. And that can be any source code file. So every source code file you execute with your Python interpreter will be executed and be your main program, so to speak. And in this case here, so in some cases you want to make sure that that you execute your script that you know that your code knows that that your script is executed as a main program from your Python interpreter and not imported as a module, because an import of a module also executes the code. So we need to differ between that. So now I created another prime extra here. It prints out. So in this case here, it prints out the name here. And there's a special variable in Python called name that actually identifies the module. And that name changes if you execute it from the Python interpreter or you import it as a module. So if I import my, let's see here. I import prime extra here, it will print prime extra. So name will be prime extra when you import it. And if I run this module, there is a command here in the notebook called run that will run my program just to have like you run it on the command line. And if you run it by typing Python on the command line, it will print out main instead. So when you do Python from the command line and then your script name will be main instead of the module name. So, and this is one way of determining. So then you can have an if statement in your module here that checks here. If name equals to main, then you know it's executed as a script on the command line, and you can start your program. If it's imported, name will not be main, and this will not be executed. So now you see here, if I run my frame, it will be, this is executed here, false and true. If I import, nothing will happen. So I import the same module here. It takes some time to get used to this. You can have it here for reference and you can look it up. Okay. Let's see how much I do this. It could be that I have to continue next time, but I'll let you know. Okay, so in the final minutes here, I will just go through some of the things that you need to know when you want to output data, for example, to files. You need to format. You need to format your data in a way that it looks nice or provides the data you want in a certain precision or so on. And that is done using the format method of a string. So I have here 4 variables, and I want to print them out using the format statement. In this case, the default format here, you can put special placeholders in your string here. So in this case, every square bracket here will be replaced by one of the variables here. So if I run this, it will print out, replace the square brackets here with the number coming in from the variable. And it will have comma signs in between. So you can look at this as a template of how you want your output to look like. It's also possible to refer to them in different order. So in this case, the number here will specify which value to retrieve. So 0 is the first one, meaning A, 1 is B, 2 is C, D, and so on. You can format strings in the same way here by specifying the field width. So you have a colon here, and it's left aligned. Now you see here, this is a string I put in, and this is the formatted string output. So it will pad your string here, pad your output here with string. So make sure that this is 15 characters. You can also justify by using the greater than sign inside the format placeholder. And now it's write justified. And if you have a raised sign here, it will center the text in the string output. You can also fill in with, instead of having spaces, you can fill in with underscores instead. And it will fill with underscores here instead. You can format integers using the D notation here. By default, just prints 42. You can specify the field width just for string. So if you have 10 here, it will have a field width of 10. So right justified, left justified, centered, and the field character here as well. Floating point values is perhaps the most complex one to format and write out. So here you have 10.2. That means the field width of 10, 2 decimals, and a fixed format. So it's not scientific notation. Looks like this. So the general field width is 10, and then you can specify the number of decimals that you want to have in the output. You can also have scientific notation by using the E code, and then present it like this. You can also have named placeholders. So you can have X and Y, and then it will place X and Y inside the placeholders as well automatically, like this. And you can have dictionaries here like this. So the keys for the dictionaries can be placed directly in the string like this, and then you turn over the params dictionary with a double stars as a prefix, and then it will just pick the things from dictionary and fill the output like this. There is a nice variable in Python called globals, and everything in Python is actually stored in dictionaries. So all objects that you create are stored in dictionaries in some way. And you can get these global variables using the globals function. So if you don't want to kind of specify, you just want to specify actual variable values directly in your formatted output, you can do like this. You can specify your variables here by the variable name, and just pass the globals, return from the globals directly into the format function. It will automatically take the variables that are defined in your current code environment. So that's also a way of doing it. I think I will wait with the file writing for the next time. So I will stop here. There are so exercises can be found under assignments. General here. Here are some exercises you can do. And 22, 21, 22, 24, 25 should be turned in with this assignment here. I haven't set any due dates yet, but I will do that shortly as well. You can wait for other lectures, or you can continue looking through this file here. There will be one more lecture on the built-in functions here as well, which I will probably do next time. So you can start with exercises and continue looking at the lecture material for the next lecture as well if you want. I will try to open up as much as possible so that you can continue on in your own pace. Any questions?
I have one question. What is it we're doing on Friday? like the tutorial.
So the tutorial, I will be there on Zoom, and if you have questions on anything on the environments, how to create your Python code, I will also ask a question and try to help you with your code.
Okay, thank you.
So there will also be a way. I will create breakout rooms and talk to you individually if you want that tutorial as well. So